A simulator and all the models and all the design of experiment work that go with it end up being a very substantial, complex software system. We all know that software can have defects. So this raises the question, how do you know that your simulation results are actually correct? How do you know that the simulation really predicts the behavior you will experience with a real vehicle on a real road, especially for scenarios that were only covered in simulation and that were not covered on a real road? There are two high-level issues to consider. The first is model accuracy and tool qualification. How do you know that your model of your environment is correct? That your own vehicle and other road users behave in the simulation the way they would in the real world? How do you know that perception as well as vehicle motion is covered? And how do you know that you've considered the right safety metrics to be monitoring during the simulation? Ultimately, this comes down to comparing the behavior of the real world with the behavior of the simulation and making sure that they're close enough that the expected safety prediction of the simulation campaign is predictive of the expected safety performance in the real world. In addition to purely experimental results, there will be a need for some level of tool qualification. Consider, if your simulation has really poor quality software that's full of bugs, it's unreasonable to expect it to produce high quality results simply by running a bunch of tests and comparing against the real world. There will be some instances of incorrect behavior due to those bugs that you might not catch during those comparisons. So there's some minimum level of tool qualification that needs to be performed to make sure your software is of high enough quality beyond just running some tests and compares. The second high-level issue for simulation validation is experimental design. You can have the world's best simulators and the world's best models, but if you don't cover the entire operational design domain of your vehicle in the simulator, then there will be pieces of the ODD that you did not stress during simulation, and who knows what will happen when the car experiences them in real life. Special emphasis should be placed on high-risk edge cases that may appear very infrequently but have high consequence. There may well be situations that only occur once every million miles in the real world, but if they have a high probability of leading to a crash, you need to be sure that they're appropriately handled by the vehicle, or you will not achieve your safety budget. Beyond making sure that your simulation campaign covers the whole ODD and edge cases, you have to make sure that validating the simulation also covers all the capabilities of the simulation. In general, this is going to require taking some real-world data and matching it to a corresponding simulation scenario. This turns out to require a significant amount of effort and is a big piece of the simulation validation engineering work. Finally, you have to make sure that the set of real-world driving you use to validate the simulation covers all of the ODD for the vehicle, as well as providing a high degree coverage of potential bugs inside the simulation. There's a famous saying that goes with this, which is, all models are wrong, but some are useful. You will never get a simulation that is perfect in every respect, and in particular, you will never get a simulation of infinite fidelity. But the approach to addressing that is not to try and get perfect fidelity, because you will never get there and it will cost too much to even try. Rather, the important part is to ask, what question is the simulation trying to answer, and make sure you have the right types of fidelity in the right degree to give an accurate enough answer to the questions you're asking of your simulator to make sure that the simulation results are predictive of safety in the real world.